Hi, Viper chemistry students. Hey, let's take a look at nuclear chemistry today. Um, First of all, we know about the nucleus now. We know about isotopes, and we can break nuclear chemistry down into three parts. Of which today I just want to talk about decay, radioactive decay. So, what you want to think about as you look through these slides is that the nucleus literally sort of breaks down and emits energy. When it does that, a lot of times the isotopes, the elements become something new, so a different element. So you'll be exploring that. Now there are half-lives for these isotopes. So, and by the way, the name of isotopes that go through radioactive decay are called radioisotopes. So that's a new term. But anyway, chemists have found that they have a unique half-life for every isotope. So as you look down through your slides, you're going to see, some reference to that. Now, here's a slide that just shows simply that we have an original 100%, and then after one half-life, only 50% of that isotope is left. And then after another half-life, 25% is left out of the whole, or 50% of 50% is 25%, and so on and so on. So that's what that's about. Now, here's just an example of how that might look in color. So, like we have 100% blue, now we have 50% blue, now we have 25% blue, now we have 12.5% blue. So that's kind of what that means. There's a graph. Now, this table here kind of shows that if you'll notice on the left, the original isotope, then after it goes through radioactive decay, then becomes the isotope on the right over there, and that's something new, something different. So that's what you're going to learn about with that. There are now, really basically, you are going to be asked to develop the skill for determining amounts. So there's going to be some problem solving involving half-life. And so you'll have to rise to the challenge. Best way to do this is use a chart, some pencil and paper, and just chart it out. Now there's some examples here. So you can see that using a chart such as this right here might be just simply write down what you start with. After the half-life, you've decreased it by 2, and so on and so forth. Each time it just divides by 2. As you go down through, you're going to see that there's, like I say, there's some practice problems to look at here. I'm not going to go through the details because I don't have time, but you will also see you will also be given some practice problems to work, and then I will be doing some videos on that. But for right now, we'll just focus just on radioactive decay, half-lives, and so on. So don't hesitate to reach out, send an email if you have questions about this. But I think you'll catch on to this after you do some practicing, and then I'll probably have some keys to the worksheets that will be available to look at as well. All right, good luck, and let me know if I can help you. Thank you.